Okay, so now we understand what is the statistical process control and the control charts. They have upper and lower control limits. Let's now understand how to interpret those results. What does those things mean that are coming from that analysis? So here we have, we collected this data on analyze and control phase. We want to know if the process is under control or not, right? And to be under control, have to be within the upper control limit. So we saw that in our last video. If it's outside, we know that there's some special cause variation going on, and we need to stop and take some action there. But also, if some points are, in a particular form, you might want to take a look, right? So remember, it is a normally distributed data set. So you imagine that most of those samples will be around the mean, but some of them, a little bit farther away using the normal distribution probability. But for example, if you have a lot of data points in one side, like up or lower, consecutive, you might think that, well, we might have a problem there, right? Because it's supposed to go up and down and not form any kind of logic that is kind of specific here, right? So if you run all of 7, 8 points on the upper part consecutive, you probably have something that's tear them to that side. If there's a trend that's going on that you're kind of consecutive going up or going down, if you repeat a pattern over time. And so these are some of the kind of problems that can tell you that something will be out of control pretty soon. I have other examples here, hugging the central line or very close to the control limits, right? So it is a normal distribution. The control limits are 3 standard deviations. So there's a very, very low probability of those data points being close to the control limits. So this is kind of examples for you guys to have. This is something that kind of a little bit more normal-ish, like going up and down and center in the middle. If you have, of course, out of control limits, we know that. If you have big runs, so this is what I'm talking about, big runs up, big runs down, it might, flag that you have a problem or you're gonna have a problem pretty soon. You have a trend going up, going down, some cycles, hugging here in the center, or too much on the sides. They're all examples of things that might be happening that you need to stop the process, take a look, take some actions there to see what's going on, right? So when using the control charts is to find out what's going on and keep measuring the process. So if something goes outside the limits, you can go back and start working and see what is the variation coming from, right? Because if it's out of the limits, it is because you have a special cause variation. So ensure that that process have a high quality. To do that, we need to have these kinds of control, and then identify what are the common, what is the special cause, and act on those special cause. So, start another DMAIC or a PDCA process. PDCA was the Deming cycle. That is the same thing of the DMAIC, just understanding root causes. So what companies do is statistical process control, and they usually more used in automotive companies, manufacturing environment, because they're in a very tight quality situation, right? So the specifications are very tight, so they have to have exactly those specifications, or you're not going to be able to assemble the car. Imagine the car has 2,000 parts that need to be assembled all together. Little modifications and variations in the specifications and the measurements of each part, the size of the part, it basically is not going to function anymore, right? So some industries are more tight on the specifications, and then why they use more those kinds of methods than the other ones. So we want to, select samples, understand if there's cause variation, and act as necessary. So this is just an example of a control chart. If you collect data, if it's like this, should we take some action, or is that behaving as we expect, right? So think about that, and you can see here that most of the dots are close to the mean. We have some that are far away, but that's expected as well, right? We don't have a big run up, a big run down. We don't have a trend up, trend down. So this looks like a normal distribution going on. There's, the as you know, the special statistical process control charts are used to identify if there's a normal or if there's special cause variation going on. But I need to determine what kind of chart I'm going to use, okay? And then establish the upper and lower control limits. And there are different types of charts depending on what kind of performance measure you have. So you have a continuous measurement, or you have an attribute. There are different ways and different charts to use, or if you can count as well. You're going to need some time series data here. And here kind of it is a flow chart that explains what kind of chart you're going to use. So the chart have variables attribute or variables if they are variables, or and then how many elements, what chart to use. So this is when you have continuous variables. This is when you have attribute variables. And then attribute variables, you can have if the sample size is fixed or not, then you can use yes for NP chart, no is a P chart. Can attribute occur more than once? So are you counting? So if you're counting, you're going to C chart or U chart. If you're just saying, if it's just an attribute, good or bad product, then you go to P chart and NP, we're going to take a look as well. So first we're going to look at continuous data, and continuous data, there's two charts that you have to do. And those charts, you saw it on the core operations management class of just kind of reviewing things very quickly. If you have a question, just let me know. But I expect you guys to see that as chapter 3 of operations management core course. So, and this is the one that I know that everybody goes through, which is the continuous data. So continuous data, you have two charts that you're going to do. One to look at the average and one to look at the range, which is the X bar and R chart. You probably remember this from last year or last semester, which basically you take a sample and then you calculate the average of that sample, and then you do the X bar chart and you calculate the range of these samples, and then you calculate the R chart, right? So X and R chart, usually the sample size are less than 10, something between 3 and 5, and this is the math around it, right? So you calculate the central line, and then you calculate upper and lower control limits here, and then you calculate R chart here, using again central line, upper and lower control limits for R as well, right? And the thing that you're going to use here is that table, the standard table that have the values of A2, D3, and D4 for when you're using depending on the sample size N, right? Is the sample size. And the next video we're going to see a problem that you guys are going to remember from that core operations class.